You know what's terrifying? A rotating column of air so powerful it can turn a pickup truck into airborne confetti. And we still can't predict exactly when it'll drop out of the sky. Yeah, today we're breaking down how tornadoes are formed, step by step, in 10 explosive facts. And by the end of this, you'll never look at a thunderstorm the same way again. Let's spin this thing up. Fact number 1. Tornadoes don't just happen. They need ingredients. And the atmosphere is basically cooking chaos. You need warm, moist air, usually flowing up from the Gulf of Mexico, colliding with cold, dry air sweeping down from Canada. When those two meet, it's like mixing Red Bull with espresso. The warm air wants to rise, the cold air wants to sink, and the sky turns into a vertical wrestling match. But warm and cold air fighting isn't enough. If that were the case, every summer storm would be tossing tractors across counties. So what's missing? Rotation. And that brings us to fact number 2. Wind shear is the invisible troublemaker. That's when wind changes speed or direction as you go higher into the atmosphere. Imagine the air near the ground moving one way, while the air 5,000 feet up is speeding in a totally different direction. That creates a horizontal rolling motion in the sky, like an invisible atmospheric log rolling through the air. Now here's where it gets wild. That rolling air, it's sideways. Tornadoes are vertical. So how does something spinning sideways suddenly stand up and become a monster funnel? That's fact number 3. Enter the supercell thunderstorm, the heavyweight champion of chaos. Not all storms qualify. Supercells are rare, organized, and dramatically overachieving. Inside them is a powerful rotating updraft called a mesocyclone. And here's the trick. When warm air rockets upward inside a supercell, it grabs that horizontal spinning air and tilts it upright. Imagine grabbing a rolling tire and flipping it vertical while it's still spinning. That's what the updraft does to wind shear. Now you've got vertical rotation. But here's the catch. Most rotating storms never produce a tornado. So what separates cool radar spin from call your insurance company? Fact number 4. The rotation has to tighten. And when air tightens its spin, physics gets spicy. As the rotating column narrows, it spins faster. It's the same reason figure skaters pull in their arms to spin like human blenders. Conservation of angular momentum. Sounds fancy. But it basically means squeeze it and it speeds up. Inside the storm, the mesocyclone begins shrinking and intensifying. Pressure drops, wind accelerates, air rushes inward. And that drop in pressure? That's the moment things start getting visible. Which leads us to fact number 5. The funnel cloud isn't the tornado. Let me say that again, because this blows people's minds. The funnel you see dangling from the cloud, that's just condensation. It forms because pressure drops so fast that moisture in the air condenses into a visible cloud. But the rotating column of air, it often touches the ground before the funnel becomes fully visible. So sometimes the damage is happening before the Instagram moment appears. And if that doesn't make you respect severe weather just a little more, I don't know what will. But wait, we've got rotation. We've got tightening spin. We've got a visible funnel forming. So why doesn't every supercell drop a tornado? Why do some storms spin like crazy and then just stop? That mystery is where things get even more intense. Because now we're heading into the part scientists are still actively studying, and this is where tornado formation goes from explained to hold on, we're not totally sure. And trust me, fact number 6 is where this storm goes from organized chaos to full-blown atmospheric plot twist. Fact number 6, not all tornadoes form from the top down. Yeah, plot twist. For years, scientists assumed tornadoes formed when the rotation in the mesocyclone simply tightened and drilled downward, like an atmospheric corkscrew. But newer research suggests that in many cases, rotation actually develops near the ground first. Read that again. Near the ground. Small-scale pockets of spinning air, caused by friction, temperature differences, and chaotic air currents, can get pulled upward into the storm. When that happens, the supercell doesn't just create rotation, it harvests it. It's less sky drill and more atmospheric vacuum cleaner. And that changes everything about how we understand tornado birth. Because now the question isn't just, is the storm rotating? It's, what's happening at the surface where we can barely measure it? And speaking of measuring, fact number 7. Tornadoes can intensify terrifyingly fast. We're talking minutes. A tornado can go from weak EF1 winds to violent EF4 or EF5 strength, faster than most people can finish microwaving leftovers. Why? Pressure drop acceleration. As rotation tightens near the ground, the pressure in the center drops even further. That drop pulls more air inward. More air rushing in means faster spin. Faster spin means lower pressure. It's a feedback loop from hell. And once that loop locks in, wind speeds can exceed 200 miles per hour. To put that in perspective, that's strong enough to rip pavement off roads and throw it like frisbees. But here's what makes it even wilder. Some tornadoes don't stay one tornado, which brings us to fact number 8. Multiple vortex tornadoes. Imagine one tornado, but inside it are smaller tornadoes orbiting the center, like chaotic little satellites. These subvortices can have wind speeds far stronger than the overall tornado itself. So while one side of the tornado might cause roof damage, a subvortex passing a few feet away can level an entire structure. It's like the storm has hidden boss levels. And these mini whirlwinds spin so fast that they can carve narrow paths of extreme destruction within a broader damage zone. Same storm, same minute, completely different outcomes depending on where you're standing. But here's where it gets even more unsettling. Fact number 9. We still cannot predict exactly which supercell will produce a tornado. Meteorologists can forecast tornado conditions days in advance. They can warn entire regions. Radar can detect rotation inside storms. But knowing a storm is rotating does not guarantee a tornado will form. Some supercells spin beautifully on radar and never produce anything more than heavy rain. Others look modest and suddenly drop a violent wedge tornado with almost no warning. The missing piece? Micro-scale atmospheric processes happening within hundreds of feet of the ground, and we just don't have enough sensors down there to fully capture that chaos in real time. Which means even with Doppler radar, satellites, storm chasers, and decades of research, there's still an element of atmospheric mystery. And that mystery leads us to the final fact. Fact number 10. Tornadoes are the atmosphere's most efficient energy release system. Think about it. A tornado condenses massive instability, temperature contrast, wind shear, pressure imbalance, into one focused, violently rotating column. It's nature balancing the books. When warm air surges north and cold air crashes south, the atmosphere doesn't gently negotiate, it unleashes. The tornado is not random. It's physics resolving tension in the most dramatic way possible. It's the sky saying, we need to equalize this energy, immediately. And when that process locks into place, when wind shear aligns perfectly, when updrafts tilt rotation upright, when surface spin tightens, and pressure collapses, you get a living, breathing vortex that can carve a scar across miles in minutes. All from invisible ingredients mixing above your head. And here's the part that really sticks with you. Every tornado you've ever seen on video started the same way. With air. Just air. Air that was a little warmer, a little colder, a little faster. Nothing supernatural. Nothing magical. Just physics pushed to its absolute extreme. And yet, even knowing all of this, There are still moments inside a tornadic storm that we don't fully understand, which means the next breakthrough in tornado science. It hasn't happened yet, and it might be discovered by someone watching storms right now. So the next time the sky turns green, the wind goes still, and the air feels heavy enough to chew, you'll know exactly what's building overhead. If you enjoyed breaking down the science behind one of nature's most violent creations, stick around. Because the atmosphere has plenty more secrets, and we're just getting started. I'll see you in the next storm.